F for analyzing frames or machines, same as the previous one. There's no difference here. It says here, draw the free-body diagram of the frame or machine and its members as necessary. You draw the free-body diagram of the whole structure if you want to find the support reaction forces, or if you want to do the analysis internally and you do not find a point where you don't have a maximum of 2 unknowns and at least 1 known force, then you use the you apply equation of equilibrium on the whole structure to get the reaction forces as the support, and then you move on into the members. But don't worry, we'll go through those examples one by one. Okay, so yeah, text is for you. I will just explain it here. Look at this. We look at the, I'm drawing the free-body diagram of BC. You know how to draw the free-body diagram of components now. For free-body diagram, I've got this. I'm looking at this one. I've got a member BC. C is pin connected, so I've got 2 reaction force here. B is pin connected, so I have B has got a 2-member force here. Look, AB is a 2-member force. There's no third force being applied on that. So if it's a 2-member force, you do know the force applies on the line of action passes through the 2 pins. Okay. So therefore, the reaction, the force at B, there's only 1 force. And then the third one is this active force acting at the center. That's how. So when I draw the free-body diagram of AB, I'm looking at this one, AB, same force in the opposite direction, and then I've got a support reaction from point A. The point A, because it's a two-member force, you always know that the force applied passes through the 2 points. Therefore, you got it. So there's no rocket science, you know already this. You can draw the free-body diagram of the whole structure, or you can draw the free-body diagram from a member inside. So let's look at an example, and then everything gets further clear. Look at the free-body diagram of A, B, C. So let's draw the free-body diagram of the whole structure. Okay, so whole structure. So what shall I do? Let me make 2 points. I've got here, this is fixed to the ground. I've got here, this is also fixed to the ground. Okay, so at point A, well, let me draw it here. At point A, I've got 2 reaction forces. Is that clear? Because AB is not a 2-force member. There is a more coupled moment being applied on the member, so it is not a 2-force member. If it was a 2-force member, I would have said that there's reaction force here. That's it. That's the only reaction force. And this reaction force I can divide into 2 components that I could do. But this AB is not a 2-force member because there is a coupled moment applied to the member. So therefore, reaction force at A, I will have 2 points. And at C, again, I've got 2 reaction forces. And I've got active and active. So in simple words, my free-body diagram looks something like this. Is this clear to everyone? Is that clear to everyone?
Yes.
Okay. So let's look at this now. The free-body diagram of member AB and BC. So let's look at free-body diagram of AB first. AB. So what I would do, I would draw AB. Okay. At A, I've got 2 reaction forces, AY and AX. At pin B, it's a pin connection. Cannot move in left, right, but can rotate. So I will have 2 reaction force at B, that would be BX and BY. And I've got a moment M here, couple moment. I can do BX here also. But because I did AX in this direction, So common sense tells me that Bx should be in this direction. But as I said, it doesn't matter if I assume wrong, the answer signs will tell me what I did. Is that the right Fibonacci diagram of AB?
Yes, sir.
Okay, so let's look at member BC. So let's draw member BC. That's my member BC. As C is a pin connection, so I've got two support reactions. That's CX and CY. I've got a force being applied, active force being applied here, which is P. And now at B, I've got two forces acting. This force is same as Bx and this force same as By, but in the opposite directions. Is that clear?
Yes, sir.
So as for you, you can have a look. Let's look at this one now. Fibonacci diagram of the member AB as well as the pulley. Pulley. I have to draw the Fibonacci diagram of this. So let's have a pulley then. As a pulley with a pivot point. So it's been pivoted at the center, so I will have two reaction forces. Am I right?
Yes, sir.
And I will have a pull force for the rope and another pull force for the rope here. So this is the Fibonacci diagram of my pulley B, which looks something like this. Is that clear?
Yes, sir.
So now let's look at the Fibonacci diagram of AB. So I've got an AB, so that's my pivot here. That's the pivot for the pulley, and I've got a load. So at A, it's a fixed point. A can rotate, A cannot move in XY direction. So I will have my two reaction forces at the Y, so at the support point A. At point B, I've got my BY, and I've got my BX. We have taken this from here. It is the same here, but in the opposite direction. We got this pin B connected on the member AB. And then on the other end, I've got a force acting downward. That's my Fibonacci diagram for member AB, which is same as shown here. Is that clear? No rocket science. Very simple. You already know how to draw the Fibonacci diagram.